Welcome back to the video lecture series for Introduction to the Art of Programming using Scala. In this video we're going to continue looking at the direct access binary files, and in particular we're going to create a class that we want to serialize out to one of these files. So if we pull up Eclipse, I'm going to go ahead and create a new package. I'll just call it extras. And inside of here, we're going to make a Scala class because it's the type of thing that I put in my code. I'm going to create a class for a particle. This might be represented, or this might represent, I don't know, a planet in a solar system, or just a baseball being thrown, something that's inside of a simulation that you're doing on a computer. So what does particle have inside of it? If I made this a mutable, it needs to have its x position, which is a double. It needs to have its y position, which is a double. I'll also go with making this 3D. And let's go ahead and carriage return there. We need velocities for each of those. I also want to include maybe the mass of the particle. We'll say our particles can't change mass. And last, I want to include a value that is an ID. It's an int. So that whatever happens with particles in memory, I can always know which particle is which. So these will be unique identifiers in there. Now there are lots of different things that we could put inside of here depending upon what it was we wanted to do with our particles. But what we want to focus on for this example is I want to have the ability to write it out to file. So I want to be able to write this to file, and in doing so I have to pass it the file that I'm going to write it to. We saw that there is this type called random access file, but if I pass in a random access file, I've limited myself to only work with random access files. It inherits from data output and data input, so all the methods that I'm going to need to call here are part of the data output. So I can make this code more general by passing in, I'll just call it out as a data output, and we'll import that. And in many ways this method is very simple. I want to have it just write out, so out dot write double of x, and then I will do the same thing for y and z. I will also do the same thing for the three velocity values. I will write out the mass, and then the last thing that I want to write is an int for the ID. What about reading these in? Well, the reading should not go inside of the class, at least not most of the time. Most of the time when we read something in, it's not to replace the values that are in an existing particle. I will want to be creating a new particle, and the Scala approach to doing that would be to have, that was interesting, would be to have a companion object. So we're going to make a companion object here, and I'm going to write an apply method that takes a data input. And this needs to return a particle. We import our data input. What does this need to do? Well, it's going to return a new particle, and it needs to pass in all of these values, which it's going to get by calling in dot read double for the first 7 values. 2, 3, 4, 5, 6, 7, and then a read int. So whatever data input is passed in, we're going to read 7 doubles and an int from there, and that is passed into a call for building a new particle. There's one other piece of information that that would be helpful to have associated with this, and we'll see why kind of in the next video, but that is how many bytes this is going to take up. And that way, if we edit the format for writing this out to file, we would also edit this other value. So how do we call it? Bytes taken. And this, we're going to use the sizes we talked about in the last video. Our doubles are 8 bytes, our ints are 4 bytes. So this has 7 values that are each 8 bytes plus 1 value that is 4 bytes. It could be helpful if you're going to do a lot of this to define some constant someplace for the size of these, just to make it so that it's more clear if someone comes and reads your code. And I don't have a magic 8 and a magic 4 sitting here, but for our purposes right now, that will be sufficient. Just to test this out, how about we go ahead and create a main in here. And I will make a new random access file. And then this needs a mode. We'll say read write. I'm missing an equal sign up here, which is making the compiler rather unhappy with me. Import the random access file, and let's make a new particle. Because I didn't write a second apply that takes all of the 8 arguments, I have to use new if I want to build one from scratch. We'll put it at 1, 2, 3 with velocity 1, 2, 3, a mass of 10, and an ID of 42. And then I want to call p1 dot write to file that random access file. I should then be able to say p2 val p2 equals particle sub raf if this file is at the right location, and I can get to that location by saying raf dot seek of 0. That'll jump it back to the very beginning of the file, and I should load in that same thing to make sure that it is there. We can print line p2.x, p2.y, p2.z, and then p2.id. I'm not going to bother printing out all the velocities. Okay. What happens if we run this? Look at that. 1, 2, 3, 42. If I come over here and I hit F5, we have a new file, particle.bin. If I open it, you can see that it doesn't look all that interesting. If we were to look at this file with, say, XXD or some other hex editor, most of it would look completely like garbage because of the doubles. The ID we might be able to figure out, though, because I picked a number bigger than 16, the fact that it would be in hex, it would not stand out as obvious as being 42. But this now gives you a simple example of how we might write something out to file, and then how we could read it back in and actually applies that. We'll come back in the next video and we'll actually write a data structure that utilizes this capability.